Hey, it's Mr. Celentano. This video is going to be explaining ternary ionic compounds. So before we talked a little bit about binary ionic compounds, and we talked about how to name them and how to make their formulas. So it was just put the metal first and then the nonmetal second in the formula, and then when you name it, the metal keeps its name and the nonmetal ends in "ide" after that, right? So for example, magnesium chloride. So here's the metal, stays in front, magnesium keeps its name. Chlorine becomes chloride, right? So this is what we went over. This is a binary ionic compound because it's only composed of two types of elements. Even though there's two chlorines here and one magnesium, it's technically three things here. It's two different types of elements, and so we make it, that's called a binary ionic compound, bi meaning two, like a bicycle. Okay, this is something different we're going to be talking about, and so we're going to be using these really big ions now. They're called polyatomic ions. Now they're called polyatomic ions because they're composed of many atoms in the ion. So poly means many, atomic means atoms, and ion just means it has a charge, right? So for example, this chunk here, C2H3O2 with a -1 charge, that's called acetate. That's a polyatomic ion. Carbonate is also a polyatomic ion, so is sulfate. All of these different things are polyatomic ions essentially. And it's because they're made of many atoms. Thus far, we've only used something called monoatomic ions, which is just ions that have a single atom in them. But these have many, and so this is going to make different types of compounds essentially. So the types of compounds we're now going to be working on are called ternary. And they're called ternary because they have 3 or more elements in them, unlike binary, which just has 2 types of elements. So they contain these polyatomic ions, and usually it's an anion. It's usually a negatively charged ion for the polyatomics. You use the name just like in the table provided. And so for example, Na2SO4 is called sodium sulfate because we got that off the list. SO4 is the ion sulfate. You also need to use parentheses if there's more than one polyatomic ion. So we're going to go through exactly what that means. So let's try a few of these out. So the first thing we want to try out is, let's try out sodium nitrate. So we know that sodium, we look at the periodic table, is Na+, right? Now let's grab nitrate from our list down here. So here is nitrate, it's NO3-. Now we know that sodium's a 1+, and nitrate is a 1-. So how many of each will we need? Well, we'll need one of each. So the formula then becomes NaNO3, and that is the formula for sodium nitrate. Again, the nitrate just came from our list here. This is called a ternary compound because it's at least 3 elements essentially in the compound. Okay, so let's try magnesium sulfate. So we look at our periodic table. We know the charge of magnesium is 2+. And then let's go grab sulfate from our list. Here's sulfate down here. Sulfate is a 2- charge and it's SO4. So we put those side by side. Whenever you go to make these formulas, you want to make sure you put the charges first. Otherwise, you might accidentally make a mistake. So this is a 2+, this is a 2-. How many of each do we need? Well, we just need one of each. And so the formula just becomes MgSO4. And that's it. Now notice we keep this 4 here. This 4 is how many oxygens are included in SO4. The rule with these polyatomic ions, these things down here, is that you're not allowed to ever change them. You can't change what's in them. The charge will go away because we'll cancel it out, but you can't change the numbers in there. SO4 is sulfate. Here's SO4. That's sulfate. And if you make that SO3, that's something completely different. If you change those numbers around, that's a different ion. We have to keep it sulfate. So we have to not touch anything in there. Don't change anything in there. So we just got rid of the charge because the 2+ canceled out the 2-. Okay, let's look at lithium phosphate. We know lithium on the periodic table is a +1 charge. We get phosphate from our list. Here's phosphate. And that's a -3 charge. So how many lithiums are we going to need to put with our phosphate in order to cancel out those charges completely? Well, we're going to need 3 lithiums, right? And we're going to be able to keep 1 phosphate because we want to keep the smallest ratio possible. And so the way we write that is simply Li3PO4. We just have 3 lithiums. Phosphate does not change anything in it, right? We can't change that polyatomic ion. We can only get rid of its charge. Can't change anything as part of it. Okay. And finally, let's look at potassium sulfate. So look at the periodic table. We know the charge of potassium is +, right? and we look at our list down here, sulfate is a 2-. So how many of each will we need to make the formula? Well, we'll need 2 potassiums, and then sulfate will stay the same. This is a chunk that we cannot change. SO4 is a chunk. So treat these ions as chunks that you're not allowed to change. Okay. But things do get a little more complicated, right? Because it can't be that easy. So let's look at, for example, magnesium nitrate. So magnesium on the periodic table is Mg2+. Okay, fine. Nitrate on our list is a 1- charge. So how many magnesiums and how many nitrates will we need to combine? Well, we're going to need 1 magnesium, and we're going to need 2 nitrates because this is a 2+ charge, and we need to get 2 minuses to cancel that out. But if we put it like this looks a little funky, right? Like, if we write it the way I currently have it, that means that I have 1 magnesium, 1 nitrogen, and 32 oxygens. So that can't be right? So the way that you have to show this is that we have to put those parentheses in. This means that I have 1 magnesium, and then this is the nitrate chunk that we're not allowed to touch, right? Well, now we have 2 of those because the 2 is outside the parentheses. So that means the 2 applies to everything in the parentheses. So it literally means 1 magnesium and 2 nitrate chunks. So let's look at another one. Aluminum. Okay, aluminum hydroxide. So aluminum is a 3+ charge. Hydroxide on our list is OH-. So how many hydroxides do we need to cancel out an aluminum 3+? Well, we need 3, right? And so we would write this 1 aluminum and 3 hydroxides. The way I currently have it written, though, this looks like aluminum and 1 oxygen and 3 hydrogens, right? But that's not what we're saying. We said we needed 3 hydroxides, 3 OH- to cancel it out. And so again, we have to use parentheses in that case. So the point is that every time you have more than 1 polyatomic ion being used, you have to use parentheses and then put the number outside to show that you have multiple of that ion. Because we're not just going to break apart a hydrogen and say we have 3 hydrogens and 1 oxygen. We're going to say that we have 3 OHs. It's extremely important. And then otherwise it's just not the correct answer. Okay, let's look at another one. This time we have calcium phosphate. So we know calcium is a 2+. Phosphate on our list is a 3-. This is a trickier one. So how many calciums do we need to cancel out phosphate if there's 2+ and a 3-? Well, we're going to need 3 calciums and 2 phosphates. So I already included the parentheses here. Again, you can't change the phosphate. It's still a PO4. But I'm saying that I have 3 calciums, so that's 3 times a +2 will give me a total of +6, right? And then I have 2 phosphates, so that's 2 times my -3 charge, and that'll give me a -6. So my 6+ will cancel out my -6, and this is the correct formula for that one. Okay, so let's take a look at our last one here. So ammonium is actually from this list. So ammonium is actually a polyatomic cation, and here it is down here. And we're also looking for sulfate. So here is sulfate, SO4 2-. Okay, now how do we put these together? Well, this is a 1+, this is a 2-. So we actually need 2 of this chunk to cancel out 1 of this 2- chunk. And if we go to do that, now if we write it like this, it still looks really funky, right? It doesn't look correct because this looks like NH42, SO4. So again, because we have more than 1 polyatomic ion, we have to include parentheses. And that's essentially how you do that one. It's similar to the other ones, and this is the correct formula. NH4, 2, because we have 2 ammoniums, SO4, 1 sulfate. Now, the last thing, be very careful because these have similar names. So for example, let's try to do magnesium sulfide. Well, that's the formula for magnesium sulfide. The "ide" ending is a different thing. That's the skill we already did. That's very different from sulfate. So the monoatomic ions, the ions that contain only 1 atom, are sulfide, nitride, phosphide. These are just a few examples, but they're often confused with our polyatomic ions, which are sulfate, nitrate, and phosphate. So be very careful when you go to do these, essentially, because sulfide is different than sulfate, nitride is different than nitrate, and phosphide is different than phosphate. Okay, so don't lose track of those. It's very easy to get confused. Thank you for watching, and remember, Chemistry is everywhere.